Let's take a quick tour of some graphs that you can create. You can create bar, block, and pie charts, two-dimensional scatter plots and line plots, three-dimensional scatter plots and surface plots, contour plots, maps, text slides, and custom graphs. To create the graphs you just saw, SAS Graph software offers a number of procedures. In this lesson, you'll use two SAS Graph procedures. You'll use procgchart to create bar charts and pie charts, and procgplot to create plots.
To get a feel for SAS Graph capabilities, let's look at bar charts, pie charts, and plots in more detail. Here's a SAS Graph program that has been submitted, and here's the output. Let's take a look at these graphs. By the way, if you create these graphs using a version of SAS other than SAS 9.2, your output might look somewhat different. The first graph is a three-dimensional vertical bar chart showing the percent of the total for each job title. Notice that the bars are subgrouped into segments based on gender. The reference lines, the legend, and the title make the graph easier to interpret. The second graph is a two-dimensional horizontal bar chart. Once again, the bars represent job titles, but here they're grouped by gender. The display of default statistics has been suppressed for this chart. The third graph is a three-dimensional vertical bar chart of salary, a numeric variable. SAS Graph has divided values of salary into 5 ranges, and the bars represent the number of sales reps in that salary range. The fourth graph is a three-dimensional pie chart. The slices represent the total salary for the job titles shown. The final graph is an overlay plot of budget by month. The program specifies reference lines, plotting symbols, a method for connecting plotting symbols, and a background color. Next, let's see how you write SAS Graph programs like this one.
In general, SAS Graph programs work like other SAS programs. SAS Graph procedures use data from SAS datasets to produce output, in this case, graphical reports. SAS Graph programs also control the format and destination of the graphics output. Regardless of which SAS Graph procedure you use, the overall process for generating SAS Graph output is the same. You'll learn to write specific SAS Graph code soon, but for now, let's look at the general steps in writing SAS Graph programs. You begin by specifying a G-option statement to set any global options that you want for your graphs. For example, you might want to reset existing options and specify borders for all your graphs. The G-option statement is optional, but usually needed. Then, you add other global statements such as title and footnote statements. These statements are optional too. Remember that you can place global statements inside or outside proc steps. Next, you write the proc step for the specific type of graph you want. Finally, to end the procedure, you use a quit statement. This example shows a Proc-G chart step that creates a vertical bar chart of job title. Notice that you can also use where statements and other SAS statements that have the same function in multiple procedures. To create a horizontal bar chart instead, we can simply change one keyword. Creating a pie chart also changes only one keyword. Making charts three-dimensional is easy too. Creating a plot requires a different SAS graph procedure, but you can see that the overall structure of the program is the same. The proc statement specifies the procedure, and a second statement, here the plot statement, defines the physical form of the graph. Now, answer a question about statements in SAS graph programs.
In light of what you just learned, let's examine the SAS graph program that created the graphs in the previous demonstration. Here's the SAS graph program that was submitted in the previous demonstration. It contains a G option statement and 5 proc steps. Each proc step contains a proc-G chart, or proc-G plot statement, followed by a statement that defines the form of the chart or plot and specifies options. The steps also contain statements you're familiar with, including label, format, where, and title statements. You can see some unfamiliar statements too. Each proc step also contains a run statement and ends with a quit statement. Notice that the output appears in the results viewer window. When you specify HTML output, the results viewer window displays your graphs. When you specify listing output, the graph window displays your graphs. Now we'll change our results preferences to listing output. When we resubmit the program, the output now appears in the graph window. We'll switch back to HTML output for the rest of this lesson.
Now, practice running a SAS graph program and before you begin coding specific graphs, you need to set some graphics options that apply to all graphs. Setting graphics options globally ensures that you know what settings are in effect for your graphs. You can also specify global statements for specific graphs. To control graphics options that apply to all graphs, you use the G-options statement. You can use the G-options statement to set values for graphics options, to reset graphics options to their default values, or both. For the accountant's graphs, you want to reset any existing graphics options to keep your output consistent. To reset all graphics options, you specify reset equals all in the G-options statement. Let's say that you also want all the graphs to have a white background. To set the background color, you specify cback equals white in the G-options statement. Notice the order of these two options. Make sure you specify reset equals all before any other options in the G-options statement. Otherwise, reset equals all will reset them. In your SAS graph programs, you can also use global statements that you typically use with base SAS procedures, such as title and footnote statements. You learned how to write these in an earlier lesson, so adding them is easy. Now, practice setting global options and adding other global statements to a SAS graph program. Now that you've learned the general structure of SAS graph programs, you're ready to start creating graphs. Let's begin by using procgchart to create the bar and pie charts for the budget meeting. The dataset Orion. Staff contains the data that you want to chart. You need vertical and horizontal bar charts organized in specific ways, and you need one pie chart. Here's the syntax for procgchart. You already know what the procgchart statement does. Remember that to create bar charts or pie charts, you specify the chart form using any of 6 keywords: VBAR, VBAR3D, HBAR, HBAR3D, Pi, or Pi3D. So this is another way of expressing the syntax for procgchart. You can use any of these 6 statements with procgchart to specify the chart type. Here's a question. Which statement creates a 3-dimensional vertical bar chart? The VBAR3D statement creates a 3-dimensional vertical bar chart, which is the first graph you'll create in this lesson. Now, notice the chart variable. The chart variable determines the number of bars or slices in a graph. The chart variable can be character or numeric. By default, the size of bars or pie slices represents a frequency count of the values of the chart variable. Let's see some examples of bar charts. This Proc-G chart step creates a two-dimensional vertical bar chart showing the number of females and males in Orion.staff. Proc-G chart creates a bar for each midpoint, which is a value that represents either one data value or the middle of a range of data values. Because the chart variable gender is a character variable, Proc-G chart displays one bar for each unique value of gender. Here's the same chart in 3 dimensions. This is a 3-dimensional horizontal bar chart. In this Proc-G chart step, the chart variable salary is numeric, so SAS Graph divides the values of salary into ranges and displays one bar for each range. The value next to each bar represents the midpoint of the range. Notice the statistics to the right of the chart. The H-bar and H-bar 3D statements automatically display these statistics. This program creates a 3-dimensional vertical bar chart of job title, using only observations where job title begins with sales rep. By the way, notice the colon following the equal sign. This is the colon modifier, and you can use it with any comparison operator to compare only a specific prefix of a character string. Here's the same information in the form of a 2-dimensional horizontal bar chart. And here's the 3-dimensional version of the same chart.
Let's submit a few Proc-G chart steps to create various bar charts quickly. We'll start with a simple Proc-G chart step that creates a vertical bar chart of gender for security personnel. Now let's change the chart variable to job title and resubmit the step. Here's the new chart. Next, let's change the chart to a pie chart. Here's a question. What do you suppose happens if we specify both gender and job title as chart variables in the pie statement? As you can see, Proc-G chart creates 2 pie charts in the same step.
To control your chart's appearance, you can specify options in the statement that defines the form of the bar or pie chart. Some options are specific to a type of chart, but others apply to all bar and pie charts. For example, you've seen that, by default, horizontal bar charts display statistics to the right of the chart. To suppress the display of these statistics, you can specify the No Stats option in the H-bar or H-bar 3D statement. This option applies only to horizontal bar charts. Notice that you specify a / before any options. Now, let's explore some options that are common to all bar charts. You can specify the Auto-Ref option to add reference lines to your graph. The Auto-Ref option displays reference lines at each major tick mark on the response axis, which is the axis that displays the scale of values for the bar chart. In this horizontal bar chart, the reference lines run from the horizontal axis. In a vertical bar chart, the reference lines run from the vertical axis. To change the number of bars displayed for a numeric chart variable, you can specify the Levels Equals option. The Levels Equals option applies to all bar and pie charts. In this example, the H-bar 3D statement specifies levels equals 4, so SAS divides the values of salary into 4 ranges and displays a bar for each range of values. If you prefer to display the range of values instead of the midpoint next to each bar, you can specify the Range option. Now, let's examine another option for defining the number of bars. You've seen that SAS displays a bar for each unique value of a character chart variable or for each range of a numeric chart variable. But suppose you want to display a bar for each unique value of a numeric variable. Here's a question. Relatively speaking, how many unique values should a numeric variable have if you want to display a bar for each value? The numeric chart variable should have a relatively small number of unique values. To display a bar for each unique value of a numeric chart variable, you can specify the discrete option. This option applies to all bar charts and pie charts. If you specify both levels equals and discrete, proc G chart ignores levels equals. This proc G chart step shows the number of employees with the job title Sales Rep 4 for individual managers. Here, the chart variable is Manager ID, a numeric variable. However, displaying this variable as ranges of values wouldn't make sense. Adding the discrete option displays a bar for each manager instead. Now, try answering a question about bar charts. So far in this lesson, you've created bar charts that display the default statistic frequency, or freq. For example, this bar chart displays the number of employees that have various sales representative job titles. But you might want to display other statistics instead. For example, you might want to see the percentage of employees for each of these job titles. To specify a statistic other than the default statistic freq, you can use the type equals option in the statement that specifies the chart. As the statistic for bar charts, you can specify any of the statistics shown here. However, the cumulative statistics C_freq and C% are not available for pie charts. In the next topic, you'll learn that in certain circumstances, you can also specify the statistics sum or mean with type equals. Let's look at an example of using type equals. If you specify type equals %, the bars display the % of each job title. Notice that the label on the vertical axis has changed from frequency to %. Before we continue, answer this question.
Now let's add options to proc G chart steps to change the display of information in bar charts. We already submitted a G option statement to reset options and specify white as the background color. Now let's work with bar charts to specify statistics and midpoints. First, let's create a vertical bar chart with job title as the chart variable. The statistic is frequency, and the midpoints are unique values of job title. Now let's add the type equals option and change the statistic to %. We'll also use the auto ref option to add reference lines to the chart, and we'll update the title statement. Next, let's change the chart form to a two-dimensional horizontal bar chart. Change the chart variable to salary and update the title again. We'll also add the No Stats option to remove the statistics to the right of the chart. Now the bars represent the midpoint of a numeric range. We'll add the range option to display the range instead of the midpoint value next to the bars, and add levels equals 3 to specify 3 midpoints. Now the chart displays 3 bars and the ranges they represent. Salary is a numeric chart variable, so let's add the discrete option to display a bar for each unique value of salary. Notice that when we used discrete, Proc G-chart ignored the levels equals option. Now the bar chart displays 9 bars. Here's a question. What does this number of bars indicate? Nine bars indicate that salary has 9 unique values in the dataset. The bars are all the same length because only one person has each particular salary.
You've learned how to specify a statistic for your chart. Now, suppose you want to display the total salary for each sales representative job title. That is, you want to summarize a variable, salary, for each unique value of the chart variable job title. To do this, you can use the SumVar equals option. The SumVar equals option specifies the variable whose value values control the height or length of the bars. This variable, salary in this case, is known as the summary variable or the analysis variable. Here's the syntax for the SumVar equals option. When you specify SumVar equals, the default statistic is sum. So the Proc G-chart step displays the sum of salary for each sales representative category of job title. Because SumVar equals requests sum or mean calculations, the analysis variable must be numeric. Here's the output from the Proc G-chart step. Now the values of salary are summed for each job title. When you use SumVar equals, you can also use type equals. However, in this case, the value of type equals can be only sum or mean. Here's another question. If you wanted to display the average salary for each sales representative job title, what options would you use? You would use SumVar equals salary to specify the summary variable and type equals mean to request an average as the statistic. This PROC-G chart step displays the average salary for each sales representative job title. Now, answer a question about summarizing variables. Let's examine the chart for a minute. The values of salary are already formatted appropriately, so you don't need a format statement in the PROC-G chart step. But you might want to shorten the variable labels and indicate the statistic you're displaying. You can add a label statement to specify the new labels. And here's the output from the revised program. To clarify the chart, you could also display the mean statistic above each bar. To do this, you can specify mean in the VBAR 3D statement. Now you see the exact value for each bar. You can also specify other statistics to display above the bars, including sum, freak, and percent. For vertical bar charts, you can display only one statistic. For horizontal bar charts, you can specify multiple statistics, which appear to the right of the bars. Another enhancement you could specify is to make each bar a different color. If you specify the pattern ID equals midpoint option, PROC-G chart assigns a different pattern or color to each value of the chart variable. Now let's consider a different problem. When you used SumVar equals, you summarized a numeric variable within categories of the chart variable. But suppose you want to divide the bars into segments to represent values of another variable. For example, you might want to display the frequency of males and females within job titles. To divide bars into segments based on the values of a variable, you can use the subgroup equals option. The variable you specify can be character or numeric, but SAS always treats it as a discrete variable rather than as a continuous variable. Earlier in this lesson, you saw an example of a discrete numeric variable, manager ID. For more information on discrete and continuous variables, click Details. To display the frequency of males and females within job titles, you specify the chart variable job title and the subgroup variable gender. In the chart, the segments represent the frequency count for each value of gender. Blue segments represent females and green segments represent males. The height of the bars represents the overall frequency count for the different job titles. Now, answer a question about subgrouping bars. Another way of showing the value of one variable within categories of another variable is by grouping. Whereas subgrouping divides bars into segments, grouping creates a separate set of bars for each value of the group variable. For example, suppose you want to create a bar chart that displays values of gender grouped by values of job title. To group bars, you can use the Group Equals option. Like subgroup variables, group variables can be character or numeric, but SAS always treats them as discrete variables. This program specifies gender as the chart variable and job title as the group variable. In this chart, the height of the bars represents the frequency count of the chart variable gender. PROC-G chart creates a separate set of bars for each value of the group variable job title. The groups are arranged in ascending order of the group variable values. As in an earlier program, if you add the pattern ID equals midpoint option, Proc-G chart assigns a different pattern or color to each value of the chart variable. Now the bars for females are blue, and the bars for males are green. Now, try answering a question about grouping bars.
Now let's create some of the more complex bar charts we've been viewing. We'll summarize a variable within categories, subgroup and group bars, and add some enhancements.
Once you know how to create bar charts in SAS Graph, pie charts are simple. This code and output should seem familiar to you from working with bar charts. Here's the three-dimensional version of the same pie chart. When you create pie charts, you can use many of the options you used for bar charts, including SumVar equals, type equals, group equals, and subgroup equals.
Now let's create some pie charts using what you already learned about bar charts. Let's start by submitting a proc-G chart step that creates a bar chart. Now let's change the H-bar statement to a pie statement and resubmit the program. Next, let's try subgrouping the pie chart by job title. We see a separate concentric circle in the pie chart for each value of the subgroup variable job title. Let's see what happens if we group by job title instead. Proc-G chart creates a separate pie chart for each value of the group variable. Finally, let's change the chart variable to job title. Remove the group variable and add SumVar equals to display the total salary for each security job title. We'll also update the title. If we specify the no heading option in the pie statement, the heading under the title will be suppressed. Now we see the total salary for each security job title.
Now, practice writing proc-G chart steps to create bar and pie charts. Now that you've finished the bar charts and pie chart for the budget meeting, it's time to work on plots. The Orion Star accountant would like an overlay plot of total budget by month for 2006 and 2007, with connected plot lines, a reference line, and a background color. You can use the gplot procedure to create plots of one variable plotted on the horizontal axis and a second variable plotted on the vertical axis. Proc-gplot can create single plots and overlay plots. To control the display of the plot, you can specify a range of values for the axes. You can also refine the plots by specifying plotting symbols, methods of connecting plotted points, a background color, and reference lines. Let's see how you use proc-gplot to create the plots you need for the budget meeting. The dataset Orion.budget contains the data that you want to plot. Here's the syntax for proc-gplot. As you learned earlier in this lesson, the proc-gplot statement specifies the procedure, and the plot statement defines the plot to create. For the most basic plot, you can simply specify a vertical variable and a horizontal variable. This proc-gplot step creates a simple scatter plot that displays values of the variable year 2007 on the vertical axis and values of month on the horizontal axis. The default plotting symbol, a plus sign, defines the points. The format statement assigns the $12 dot format to year 2007. Here's the plot that the proc-gplot step creates. Notice that the entire graph appears in one default color, and the plotting symbols are not connected. You can add a label statement to make year 2007 more meaningful, but remember that you also need to specify plotting symbols, connecting lines, and other enhancements. To enhance the plot as needed, you can add one or more symbol statements. Using symbol statements, you can specify plotting symbols, plot lines, and color. You can also specify an interpolation method for joining the plotting points. Here's the syntax for the symbol statement. Symbol statements are global, and each symbol statement controls the appearance of a separate plot. These are the options in the symbol statement. You can remember them as value, interpolation, color value, and color interpolation. This is the original plot. And this is the plot displaying the label statement and symbol statement enhancements. Here's a question. What plotting symbol and interpolation method does the symbol 1 statement specify? The plotting symbol is a dot, and the interpolation method is join. Now, try answering a question about creating plots. This plot is attractive, but for the budget meeting, you need to create an overlay plot of monthly budgets for 2006 and 2007. To overlay multiple plots on the same set of axes, you use a plot statement that specifies two separate plot requests. Here's the syntax for overlay plots. Notice that you specify two vertical variables and the same horizontal variable twice. Then you specify the overlay option and any other options that you want. In this example, the plot statement specifies the two plot requests shown along with the overlay option. This program creates an overlay plot with the variables year 2006 and year 2007 on the vertical axis, and the variable month on the horizontal axis. Notice the symbol to statement. This program specifies multiple symbol statements to define the individual plots separately. Here's a question. What are the plotting symbol and interpolation method for the second plot? The plotting symbol is a triangle, and the interpolation method is join. Let's make a few enhancements to these plots. This is the plot you need to create for the budget meeting. It displays the overlay plot you already produced. You need to add two other enhancements, a reference line and a background color. To add these enhancements, you can use options in the plot statement. The vref equals option specifies a value on the vertical axis where procgplot draws a reference line. The cframe equals option specifies a background color. Two other useful options are h-axis equals and v-axis equals, which control the range of values for the horizontal and vertical axes, respectively. The axes on your plot are already what you want, so you don't need h-axis equals and v-axis equals here, but we'll add them to the code anyway so that you can see their values. The vref equals option requests a reference line at 3 million on the vertical axis. The cframe equals option specifies a hexadecimal color value for the background color. If you wanted to specify the existing range of values for the axes, you could specify the v-axis equals and h-axis equals options as shown here. Now your plot is finished. Of course, you'll want to add a descriptive title.
Now let's create and enhance single and overlay plots. Let's try writing a procgplot step to read Orion.yearly sales hires and create a single plot of hires by year. As we expected, the result is a white graph with plus signs for plotting symbols. Let's add a symbol statement to specify star as the plotting symbol, join as the method of interpolation, and green as the color for both. Let's also specify a reference line at 25 on the vertical axis. Now the plotted points are connected, and we see two major increases in hiring in 1974 and 2006. Next, let's create an overlay plot using the dataset Orion.budget. We'll plot three variables, year 2003, year 2004, and year 2005, against month. To overlay the three plots, we'll specify the overlay option, and we'll add a reference line at 2,500,000 on the vertical axis. For the two new plots, we'll add two more symbol statements with different color specifications each, and we'll modify the title and add a label. Finally, we'll add the cframe equals option to specify the color very light gray as the background color. Here's a question. What's the trend in these three plots? The budget is higher every year, but otherwise similar by month.
Now, practice writing proc-gplot steps to create single and overlay plots. The Orion Star Accountant likes the graphs you created, but now that you know how to create graphs, you're curious about other enhancements you could make. You've started thinking about styles, colors, fonts, and so on. Let's see what you can do to add these features. You've seen that SAS Graph uses default values for colors, fonts, text size, and other graph attributes. You can override these defaults in 3 ways. You can specify an ODS style, as you learned to do in a previous lesson. You can specify options in a GOptions statement. Or you can specify options in global statements and procedure statements. Options in procedure statements and global statements, including the GOptions statement, override individual style elements, so you can easily customize the appearance of any graph. Let's start with ODS styles. You learned how to use ODS statements in a previous lesson, and specifying a style is an easy way to enhance a graph. To specify an ODS style, you simply add the Style Equals option to the ODS statement. For example, this ODS HTML statement creates HTML output of your 3-dimensional pie chart using the gears style. Here is your original pie chart. And here is your pie chart created using the gears style. The gears style makes your output attractive, but suppose you want to change the font, color, and height of all the text in the pie chart. You can add the F text equals, C text equals, and H text equals options to the GOptions statement to control the appearance of all text in the graph. In this example, the F text equals option specifies the Albany AMT font. The C text equals option specifies dark blue text, and the H text equals option specifies a text height of 6%. Here is your pie chart created with the GOptions statement in effect. Notice that the GOptions options override the ODS style specifications. Now, answer a question about ODS styles and GOptions appearance options. Finally, let's see how you specify options in other global statements, such as title and footnote statements. For SAS Graph procedures, you can add options to control the appearance of your text. F equals, or font equals, specifies a font. C equals, or color equals, specifies text color. H equals, or height equals, specifies text height. You can specify the units of height as percent of the display, inches, centimeters, cells, or points. J equals, or justify equals, specifies left, right, or center text justification. In this program, the title statement specifies 5% text in the CentBI font, which is an italic font. The footnote statement specifies green, left justified text. Here is the pie chart with the title and footnote statements in effect. You can see that these options override both the G options and the ODS style specifications. For the moment, you've satisfied your curiosity about enhancements to graphs, and the Orion Star Accountant is gone. To make your SAS graph programs more efficient, though, you need to learn more about the structure of SAS graph programs. In particular, you need to learn how to create multiple graphs in a single procg chart or procg plot step. So far in this lesson, all the SAS graph programs we saw contained a proc statement. But SAS graph procedures such as procg chart and procg plot can use run group processing, which means that you can produce multiple graphs without resubmitting the proc statement every time. A run group is a group of statements that contains at least one action statement and ends with a run statement. Let's see what this means. Here's an example of run group processing. In this program, the procg chart statement begins the procedure, and the procedure stays active until it encounters the procedure, and the procedure stays active until it encounters a proc, data, or quit statement. Then, the vbar statement produces a chart, and this run group ends with a run statement. In the next run group, the pie statement creates a chart, and then the second run group ends with a run statement. Finally, a quit statement ends the procedure. It's a good idea to end SAS graph procedure steps with a quit statement, particularly when you use SAS graph with the ODS statement. Running too many procedures without a quit statement can use up a lot of memory. Now, let's add some plots to the program. If you submit this portion of the code, the procg plot statement ends the gchart procedure and starts the gplot procedure. Then, the first run group with the plot statement creates a single plot. The next run group with the plot statement creates an overlay plot, and the quit statement ends the gplot procedure.
Now let's enhance SAS graph output with an ODS style, global options, and options in title and footnote statements. We'll also use run group processing to create multiple graphs without submitting the procedure statement each time. We'll start by submitting a program from earlier in this lesson. It creates a vertical bar chart with a white background, and the pattern ID equals midpoint option colors the bars. Now let's specify the ODS style Ocean and resubmit the program. Notice that the ODS destination is HTML, so the style will affect only graphs in HTML format. Notice that the text fonts and colors have changed, along with the background color outside the chart. Pattern ID equals midpoint still specifies colors for each bar, but now uses a different palette. Let's change the style to gears. The chart colors and text features are different once again, and the chart has a background image. Now let's submit a G option statement to change attributes for all the text in graphs. We'll also add a title statement without any text options. We can see that the G options are overriding the text options in the ODS style and controlling all the text in the graph. Next, let's edit the title statement to add text options for color, size, and font. We'll specify a 5% high black title. The title statement options override the global text options for the title only. Finally, let's use run group processing to add another chart to this proc G chart step. We'll add a pie statement and a run statement. Then we'll submit only these two statements. The results window now shows both charts under the G chart output. Both charts are stored in the same HTML file, so we can scroll in the results viewer window to see the pie chart. The ODS style options, G options options, and title statement options also apply to this output. Remember that we need to submit a quit statement to end the procedure. Now we're done.
Now, practice enhancing graphs and using run group processing. Here's what you learned in this lesson. Now, test your understanding by taking the lesson quiz.